Hi, Algebra. Today we're going to look at section 4.5. So we are going to graph using slope-intercept form. So as a warm-up, let's just review a few skills that we've been working on. And these are all going to be on your C Notes worksheet that you have, so you can stay organized with your notes for today. So warm-up number one, we're going to rewrite this equation so y is a function of x. Remember, that just means solve for y. So if I want y to be by itself, and what I need to get rid of is the 5x, so that y is the only thing left on the left side of the equation. So 5x minus 5x is 0. So on the left, I'm left with y. On the right-hand side, I have an 8 and a negative 5x. And these are not like terms, so I can't combine. So when I rewrite so that y is a function of x, I get y equals negative 5x plus 8. Number two, if I want to find the slope of the line that passes through negative 5, 6 and 0, 8, then I need to find my change in y over my change in x. So I'm simply going to subtract my two y values to find my change in y. So that's 8 minus 6 over my change in x, which is 0 minus negative 5. As I simplify, 8 minus 6 is 2, and 0 minus a negative 5 is the same as 0 plus 5. So that becomes 2/5, and that is in lowest term, so I can leave that. On number 3, if I'm going to find the intercepts of the graph of the function a equals 20t minus 600, then I will find one intercept by substituting 0 for the other. So if I want to find my a-intercept, then I'm going to substitute 0 in for t. And now that I've substituted, as I simplify, I find that when t is 0, then a equals negative 600. So that would be my a-intercept. So as you're looking at this, you might be trying to think how this relates to the forms that we're used to. And if you look closely, this is in y equals mx plus b form. So a is really like our y, and t is really like our x, because this is written so that a is a function of t. So in thinking of this a-intercept as a point, a is really like my y value. So the coordinates would look. Now to substitute 0 in for a, that's going to help me find my t-intercept. So I'll put 0 in for a and simplify my equation now. So I will start by adding 600 to both sides. And we end up with 600 equals 20t. So we're running short on room, but our last step here would be to divide both sides by 20. So we get t equals 30. So to think about this as a coordinate, or as coordinates, remember that t is kind of like my x in this case. So if my t value is 30, then my y would be 0. So this is the coordinates for this point.
Hey kids, isn't math fun? Miss you guys.
Oh my gosh, special word for my assistant. So on your note sheet, you have some blanks to fill in, and that's going to come from this box here. So we are looking at the at slope-intercept form. So a linear equation of the form y equals mx plus b, that's your first blank, is written in slope-intercept form when m is the slope and b is the y-intercept of the equation's graph. So we have kind of talked about this a little bit before in class, but you'll remember that slope, as we talked about on your slope note sheet, is m, that coefficient of x, and this is what it would look like in a real example. Your y-intercept is the constant that we're adding to our x term. So it could look something like this in real life. So on our graph, if this is the equation of the graph of the equation y equals 1/3 x plus 1, then you can see my y-intercept right here at +1. And from here, I can use my slope to calculate my next points. So I'm going to use rise over run, and I know that from my slope, I'm going to rise 1 and run 1, 2, 3. And that next point puts me right back on my graph. So when you are given an equation, it's really easy to identify the slope and the y-intercept of the line as long as it's in y-intercept form. So remember, you always want to make sure it's written in y equals mx plus b form. So on example A, that one is all set to go for us. So our slope is our m term, coefficient of x. So in this case, 3. And my y-intercept is the b term, including the sign. So it's the constant that I'm adding to my x term. So in this case, a +4. On letter B, though, we have an equation that's written in standard form, 3x plus y equals 2. So let's go ahead and solve for y to get this in slope-intercept form. So if I want y by itself, I need to get rid of 3x. So I will subtract 3x from both sides. That leaves me just with the y on the left-hand side. And on the right-hand side, I have a -3x and I have a +2. So that it's in y equals mx plus b form, I'll write it with my x term first. And now I can find my slope because it's my coefficient of x, so in this case, -3. And my b, my y-intercept, is the constant that I'm adding to it, so a +2. So we'll go through those same steps on part C because, again, I have standard form here, and I want it to look like slope-intercept form. So if I want y by itself, I'm going to have to get rid of this multiplication by 3, and I'm also going to have to undo this -6x. So I'm going to start by adding 6x to both sides, remembering that I can only combine like terms. So on the left-hand side, I have 3y, and on the right side of the equation, I have 6x plus 12 because those are not like terms and they won't combine. So now I'm ready to undo my multiplication here. So to undo the times 3, I will divide by 3 on both sides. And as you'll remember from chapters 1 and 2, when I have an addition expression all divided by 3, I need to take each term and divide it by 3. So first I will do 6x divided by 3, which is 2x, plus I will take 12 divided by 3, which is 4. So in slope-intercept form, my equation is y equals 2x plus 4. So my slope would be 2, and my y-intercept is a +4. So go ahead and take a second to try letters D, E, and F on your own, and pause the video while you work so you can check your answers. Okay, double check. Make sure that you got a slope of 9 and a y-intercept of 12 on letter D. Slope is 14 on E, and your y-intercept is a -2. Remember to watch the sign there. And on letter F, slope is 2/3 and y-intercept is +3. So now let's look at identifying the slope and y-intercept of lines whose graphs are shown. So when we're given a graph, we want to make sure that we can identify the slope and the y-intercept. So the y-intercept is a good place to start because it's easy. It is our point on the y-axis. So in this case, my y-intercept, or my b, would be a +3. Now from that point, I can count my rise and my run to the next point on my graph, which is down here. So from my y-intercept, I'm going to rise negative 1, 2, 3, 4, and I'm going to run positive 1. So that gives me a slope of negative 4 over 1, or you could simplify that to negative 4. Let's try the same thing on number 2. First, let's find our y-intercept. This time the point's not labeled for us, but I can see on my scale that I'm counting by ones, so this would be a y-intercept of negative 3, and from this point I can count my rise and run to the next point on my graph. So from my y-intercept I'm going to rise a positive 1, 2, 3, and I'm going to run a positive 1, 2, 3, 4. So my slope in this case would be 3/4. Remember from your slope note sheet that we can tell just by looking at the graph of number 1, as I read from right to left, I'm looking at this line and it's sloping down, so I could expect a negative slope. And on number 2, as I look at this line sloping up from left to right, I would expect a positive slope. For our third example, we're going to identify the slope and y-intercept of the line with the given equation. So more practice here on converting to slope-intercept form and then labeling our slope and y-intercept. Hopefully on number 3 you identified the slope as 1/4 and the y-intercept is negative 2. Number 4 we already previously worked, so I will skip past that one. Let's look now at graphing the equation. So if we know that in slope-intercept form y equals mx plus b, we know that my y-intercept is a great place to start on my graph. So as I look at my equation, I'm going to look for my b value as the first point on my graph. So if I have an equation like y equals negative x, then I know technically I'm adding 0. So my y-intercept in this case would be the origin, 0, 0. Now from here I can use my m, my slope, to calculate the rise and run to help me find the next point on my graph. So in y equals negative x, my m is always my coefficient of x, which in this case is a negative 1. So from the origin, I can go down 1, right 1, down 1, right 1, or I could do a positive run, or a positive rise and a negative run. And from the origin, I could go up 1, left 1, up 1, left 1. And since I'm given an equation, I can connect my points in a continuous line and put arrows on the ends. On number 6, here I have a clear y-intercept of positive 2. That's my b value. So I can put my points on the y-axis at positive 2. And from here I can use my slope, my m, to calculate my rise over run. So from here I can go down 1, right 2, down 1, right 2. Or from my y-intercept I could also go positive rise, negative run, positive rise, negative run. And then I can connect my points in a straight line and put arrows on the ends. If we look at 2 more examples like this, I notice in this equation that I don't have exactly slope-intercept form. So I want to rewrite this so that it's in y equals mx plus b form. So I just need to simply rearrange my terms here. So I still have a positive 2x and a positive 8, but if I rewrite it this way, I can more easily identify my slope and y-intercept. So my y-intercept is positive 8, so on the y-axis I'll put my point at positive 8, and from here I can use my m, my slope, to find some more points. So rise 2, run 1.